Hey there, in this video we are discussing the do-while loop, which is in sections 5.3 to 5.5 in the Gaddis C++ book. So remember, here we are in chapter 5, we're going to see three different looping constructs, and this is our second. Right? The first one was the while loop in the last video, and then here's number 2, which is the do-while loop. You know, similar in some ways. So the do-while loop is going to look like this. You're going to see the keyword do. You're going to see the body of the loop, maybe one statement or maybe something in curly braces. And then at the end, you're going to see the keyword while and the Boolean expression about whether to repeat it. So the difference between this and the while loop, the do-while loop here is what we'd call a post-test loop. The test about whether to repeat it is happening at the end of the construct, as opposed to the while, which we would refer to as a pre-test loop, where the Boolean expression is being tested at the beginning. So if you think about that, among the differences, the while loop might actually never happen at all. If you get to the while loop expression and it's false to begin with, you actually will just skip the body and never do the body at all. Like maybe if I was comparing the count to 0, it would happen 0 times. But here with the do while loop, you will definitely do that statement in the body at least once. You're going to come into the do, you're going to do the statement at least once, and then you'll check on this while expression about whether to go back to the do and do it a second time. Okay, so there's at least one subtle difference. And again, that statement can be a whole block in curly braces, so there's that. Okay, so while loop, a pretest loop, do while, a post-test loop. The while expression being tested is at the end instead of the start. So here it is in flowchart form, right? The program's happening, it's happening, it's happening. You get to the statements in the body of your loop. It's definitely going to happen at least once. Then at the end, you get to your Boolean expression test. And if that's currently true, then you're going to go back to where the do is, and you're going to do it again, right? With the while loop, the expression test came before the statements in the body. At some point, it'll be repeating, and the expression will have to become false, and that's how you get out of the loop and go on with the rest of your program. Remember, if the expression never becomes false, you've got an infinite loop on your hands, which is almost always a mistake. So here's an example of that in the book. This is program 5.7, and the goal of this program is to average 3 test scores. But in addition to that, we've done that kind of thing before. But in addition, you know, if I'm running a class and I'm computing final grades, I'm not doing that just for one student. I have to repeat that job for all the students in all my classes, maybe like 25 or 30 students per class. So this program is set up to handle that. It's going to repeat that calculation as many times as the user wishes. So starts off and it declares data. So declaring 3 integers for the 3 test scores. Again, I didn't write this program, but this actually does match what happens in my courses. I actually do give 3 tests in each class per semester. So I could totally use this. You'll have a double variable to hold the average. And then there's this character where you're going to be asking the user yes or no, do you want to do it again for another student? We've seen that before of, you know, having a decision based on a Y or N input as a character, so not too surprising. So here is our first do while loop. You see the do is on line 12, and then there's an open curly brace, which represents the start of the body. And the body of this loop is fairly big. It goes all the way from line 14 all the way down to line 24, and it doesn't end until that closing curly brace down on line 25. So everything from 13 down to 25 is the body of this loop. Then there's the while statement. Now, for what it's worth, what's happening in there is, you know, what we've seen before. Prompt the user for the 3 scores, sit in the 3 scores, compute the average, print out the average, and then the interesting thing is right at the end, prompt the user for, do you want to average another set, yes or no, right? Sin in the Y or N into again, and the check here on line 25 is we're going to do it again while again is equal to the character uppercase Y. Remember what the symbol is here? That's the symbol for or that again character is equal to lowercase y. So for the first time, this is how you can handle both uppercase and lowercase input from the user. I mean, they're probably going to type in lowercase y, all things considered. But maybe they've got the caps lock key on and they type in uppercase y instead. So this is how you can handle either one of them. Whether that character is capital Y or lowercase y, that represents yes, and that would send you back up to line 12, and you would do the body of this loop again, right? And you'd keep going as long as the user types in Y. If they type in N, or frankly anything else here, that while statement becomes false, the loop ends, right, avoiding an infinite loop, and then the program's going to terminate. So let's test this program 5.7 here, our first example of a do-while loop. Remember, the main goal of this program is to average 3 test scores and then maybe do it again, and maybe do it again for however many students the instructor has. So I'll compile this, and obviously that works. Close the compile log, and now I'll start running it. You know, and oftentimes I would actually write a formal test script on paper before I started dealing with this, but maybe I can do this in my head. So when I'm testing programs like this, again, the very first test case I want should be incredibly simple, the simplest thing I can possibly think of, to make sure that I can confirm in my head that it's doing the average right. So, I mean, the very simplest thing I can think of is like maybe all the same number. And notice that we are getting 3 pieces of input on one line there, so I have to separate it with spaces. I could have used enters, right? But I want to save some space on screen right this second, so I'll just use spaces. And it says the average is 90, and obviously that is correct. Do you want to average another set? I'm going to say yes. Notice I'm typing in a lowercase y for the response there, and that's perfectly fine because this line 25 here, the while test, is using OR to catch both uppercase and lowercase y, so this will be perfectly fine. So enter another 3 scores and I will average those. Again, you know, fairly simple stuff. If I have 70 and 80 and 90, I know what the average is the number in the middle. Yeah, the average is 80, so that looks correct. Average another set. You know, what if I have 0 and 90 and 60? I don't want the numbers all in order for every single test, right? I want to make sure that this handles if the numbers are going up and down and up and down. That adds up to 150. Divide by 3, that ought to be 50, right? Yeah, okay. Yeah, I'll do another one. You know, and then I start using somewhat crazier numbers like 50 and 60 and 85. Okay, so I feel like maybe this I can just estimate. That adds up to, I guess, 195. Now, if the total was 200, I feel like this ought to be a little less than 70, right? This ought to be in the 60s, I think. Okay, the average is 65 for us, right? You can check that with a calculator. I was just kind of estimating there. And, you know, if I have integer numbers, the average still could come out to be a decimal. So I want to make sure that I test something that comes out to be a decimal and make sure that works, like 45 and 78 and 97. Okay, so the average is 73.33 repeating is what that's saying there. So I could check that with a calculator again, confirm that, and as far as I can tell, this program is working correctly. You know, I suppose I should test to make sure that the input handles an uppercase Y, right? In case you've got the caps lock key up. Yeah, okay, so if I say uppercase Y, it does it again. Get another 3 scores to average. 90 and 98 and 100. Okay, and the average is 96, great. So I think that's good enough. Let's assume that that's all the students in my course, and then I can hit N, or actually any other letter, and the program ends. Great. So it looks to me like that program's doing what we want. Now I will say this, so this is a nice technique, right, to get, you know, do multiple calculations in one single run of a program. I will say, you know, don't do this in every program, okay? So don't put every single assignment in this class inside a do-while loop like this. Only do this if the assignment asks for it. So if, you know, you have to follow the specifications for an assignment or a programming job very carefully. And if the person that gives you the job, you know, doesn't say to do this, then you know, don't do it. Then they're not expecting to see that, and they might actually have a problem on their end if they're caught in a loop for some reason like this. So only do one of these do-while loop repetitions if the assignment asks for it. Other important stuff that you can use a while loop or a do-while loop for. Actually, for this, you could use either. So it's best to use a loop to validate user input cleanly. We first discussed that in chapter 4, and we had examples where we use an if statement, which honestly is really not the best way to do that. The best way is to use a while loop. And so what you would do is you'll get some input, right? You won't have an if, you'll have a while statement that says while the input is bad, in whatever counts as bad, go into this body, throw up an error message, and then ask the user to try it again with another SYN statement. And then what'll happen is you'll come back to the while statement, you'll check it a second time, and if it's still bad, right, throw up the error message again until they get it right. So in pseudocode, it would look like this, right? Read an item of input, obviously that's a SYN statement, plus a prompt. Then there's a while statement. While the input is invalid, display an error message, read the input again, which again is a prompt plus another SYN statement. So this is really what ought to happen. You can see the exact code in the book. We could write this as a do while statement, actually. It doesn't save you any space on the screen, so this is, what we have here is perfectly fine. You could have put this in a do while loop because obviously you need to read the input at least once, right? Then you would have, in that do while loop, you would have an if statement to check whether the input is bad, throw up the error message, and then come back to the do if it was bad. So you could do that, but it's perfectly fine to use a while loop here as well. So this is really the best way to do that. All right, let's see an example of this in program 5.5, a slightly larger program, fits on 2 slides here in the lecture. And this program is going to calculate the number of soccer teams that a youth league may create from the number of available players. And input validation is demonstrated with while loops. So to be clear, you're running a youth soccer league, and I don't know, 63 people come, 63 children come to sign up for it. Each team has to be a certain size under the rules of soccer. So this will automatically compute how many teams you can make according to the rules of the minimum and maximum team size is what's going to happen. And like we're saying here, the important thing we're going to keep an eye on is doing the input validation for legitimate numbers, and we wanted to use while loops like this, and that's exactly what this program is going to do. So it sets up these constants for the minimum players on a team, which is 9, the maximum number of players, which is 15 for this example. You have some variables for the total number of players in the league, right? The number of players per team, the number of teams, and then also the number of players left over that don't fit cleanly into a particular team because of the division. So here's the first prompt on this slide, right? So prompt the user, how many players do you wish per team? And it's got to be in this range of 9 to 15. So you SYN in the user's response to team players, and the very next thing that happens is we're going to validate that input with a while statement, right? And we're checking to see if it's bad is what the while is doing. So while team players is less than the 9, or team players is greater than the 15. Remember, we use or to check whether a number is outside a range for an error check like this. That's what we said we were probably going to use or for that when we introduced it. So if it's bad like that, then come into the body of this while loop, print this error, right? And the error says you should have at least 9, but no more than 15 per team. And then you have to get the input again. So prompt the user again, how many players do you wish per team? And they get a second chance to type in a legitimate number into team players. And then it comes back and it checks it again, right? And maybe the user makes an error a second time. And you throw up the error message again and try it again and keep going until the user finally gets a clue and types in a legitimate number. And then on the second slide, right, we're going to get the other piece of input, which is how many total players signed up for your league. So similar. You get a prompt, you get a SYN statement for players. The very next thing is you're going to validate that input. Here's the while statement checking that players really should not be less than or equal to 0. You need to have some players in your league. So that would be bad. That would be a bad number to try to handle. So if that's the case, you come in here, right, throw up an error prompt, and it says, please enter 0 or greater, some kind of legitimate number. I actually think that should be specifically greater than 0, but good enough. And then you SYN into players again, and you'd come back and you'd check that, right? And the user, if it's bad, the user will try again and again and again until they get something that's okay. All right. And then once you've validated that you have a legitimate number of players per team and you have a legitimate positive number of players in the league, then you can go on, do the division, which tells you the number of teams you can make, right? Use the modulus operator to get the remainder, which is going to tell you how many players are left over. and then print, there will be this many teams with this many players left over. So let's test this program here with proper input validation using while statements. Compile this, program 5.5 out of the book. Compiled it, now I have a program I can run. Okay, so the program asks, how many players do you wish per team? Now remember, that's supposed to be between 9 and 15. Okay, so a proper test here will be me pretending that I'm a user that is foggy at the moment and doesn't know what the range of numbers is. I mean, I suppose this program would have been a little better to tell you up front. But anyway, I know what the range is. So let's say the user types in something incorrect, like 20. All right, so we've hit that first while statement there. It's kind of down below here. So it's checking that on line 25, and where 20 is greater than the 15, the maximum number of players, we've gotten the error message. Let's put that back down here. It says, you should have at least 9, but no more than 15 per team. And then it asks me again to correct that faulty input. Okay, so maybe I'm not paying attention. I type in 25. And I get the error message again, right? And it's going to get me to respond again, hopefully with correct input. What if I say 5, only 5 players per team? Obviously, that won't work for a soccer team, so you get the error message again. So hopefully at some point you get the clue, and maybe I'll say, okay, now I get it. I want 10 players per team. Okay, so now you're going on to the other question that's further down in the code. How many players are available? And remember that the main thing is you need a positive number. It doesn't make any sense to be negative. So if I put in negative 10, right, it gives me this error here and asks and prompts me to enter something legitimate. Please enter 0 or greater. And maybe if I put in negative 20, right, or negative 50 or negative 1, the computer is very patient, right? It'll keep doing this while loop over and over and over again until the user finally gets the lesson. So, finally I'll say maybe I have 62 players. So it does the division, and once you have the legitimate input of 10 players per team and 62 total players in the league, it says, yeah, there's going to be 6 teams and there's going to be 2 players left over that you have to think of something to do with. So that's working correctly, I think. Now, let's think about that. Remember, so when you are getting input, right, you get a prompt and you get a SYN statement, sure. Let's think about how this is working. The very next thing is the validation, right? So we have said previously, to emphasize this again, we've said that error messages should be clear and specific and immediate and tell the user how to do the problem. And again, this validation does all those things. Right after the SYN statement, the very next thing is the while that does the check, right? I'm not getting more input. I'm not doing another SYN and another SYN and another SYN and then start doing while statements to validate it. I'm validating this one piece of input immediately as the very next thing. That's how that ought to work, right? So even on screen, if I'm thinking about team players, then I have the validation for team players right next to it while I'm thinking about it, and that's what's happening here. The error message is clear, right? It's specific to this particular piece of input. It's not just saying bad number, right? It's saying specifically thinking about the team players, you've got to have at least 9 and no more than 15 players per team. So it's clear and it's specific. And then it asks for the user to fix the problem, right? It says very clearly, you're going to have to tell me how many players you actually want on team, and then you get a second attempt or a third attempt at inputting a legitimate number. Okay, so I like this a lot. Right after the SYN, here's the validation. It's immediate. The error message is clear and specific, and it tells the user how to fix the problem. So the, and why I'm emphasizing this is sometimes I see beginning programmers that try to, do it later. Like I've input a number of players and a number of teams and, a number of players per team. And then 5 minutes later, I get an error message that says, oh, the number of players per team is invalid. I'm going to wipe out all your data and you're going to have to run the program again. And I get a little bit irritated as a user that I've lost all that time typing in all that data that I didn't know the very first thing was bungled and illegitimate. And the other thing sometimes I see beginning programmers is they kind of try to cheat this and have one single loop that does all the validation for all the numbers they ever typed in. And so, it's less typing, but then the error message is just bad number. And I have no idea which number was wrong or what I can do to fix it. So this is a really good example here of a proper input validation with while, and you really ought to do this like the book does in this section. And then, the final thought is don't use if, right? We did see examples of input validation with if in chapter 4. Honestly, those are not good examples. Because if you think about hypothetically, if you'd made line 25 an if, and I see, in the past, I've seen beginning students get hazy about that and they make it an if, is that'll catch one piece of bad input and you'll get an error message, okay, and you'll get a second chance, but then it doesn't go back up to the if on line 25 to check that. It would just go forward with invalid data the second time, right? You would only get one single opportunity to check it. So if the user just makes one mistake, okay, an if would work. But if the user makes 2 or 3 or 4 or 5 mistakes, the program would actually truck forward with bad data, which is not what you want. So you definitely want a while here to confirm that they finally get it right. Do not use an if statement for your input validation. Now that you know about loops, you know the right way to do it. Do not use an if statement for validation. Do this. Other stuff. Here's a technique we call using flags, which we use quite a bit. And in fact, we'll be using flags in the next lab that we do in person for our class. So a flag is a Boolean or integer variable that signals when a particular condition exists. So usually we use a Boolean for this, true or false, reporting whether a thing of interest has happened or not. You're going to use this in conjunction with a loop. So a loop's going to repeat some stuff. And the flag is what is going to keep track of whether a particular thing happened in that loop ever on all these iterations. So before the loop, you'd make this Boolean, you'd set it to false, saying, well, this hasn't happened yet. Get into the loop, do a bunch of stuff. In the loop, there'd be an if statement nested in the loop that checks whether something has happened or not. And if so, then you set the Boolean to true. So after the loop, right, you can check in on the Boolean, and if it's true, that thing happened. If it's false, it never happened on any of the repetitions of that loop. So I usually use a Boolean for that. You could use an integer, which is kind of old school style. Remember, 0 counts as false, and anything else really counts as true. So you could use an integer that's either 0 or 1, that would work. As with other variables, remember, if you forget to initialize it at the beginning before the loop, it's going to hold random garbage. So it could start out either true or false, and that would be bad if it started true, because then even if the action never occurs, the Boolean is going to say that it did. So don't forget to initialize your variable to false before the loop. Here's a quick example, kind of a conceptual example of that. So let's say I have a program that's an auto racing simulator. For what it's worth, my first job actually was working on an auto racing simulator in C++ for what it's worth. So this is actually why this example is on my mind. So I was working on track control, like race control that assesses the rules of auto racing for what that's worth. So track control should watch for danger or debris on the course. And in real life, if there's trash or dangerous stuff on the course, they wave a yellow flag to tell everybody to stop racing, slow down, and watch out for that debris so you don't crash. So every lap, there'll be a loop representing a watcher inspecting each car as it goes by. So you have a while loop that says, while there's another car, and while there's another car, and here comes another car, and we'll look at all of them and find out whether anybody's damaged or not, whether they're throwing debris onto the course. So before the loop, right, before the loop even starts, I could define a flag variable. It'd be a Boolean. I would call it caution flag, and I'd set it to false. I haven't seen any danger yet, so it's currently false. Now, I have a while loop that's saying, while there's another car, while there's another car. In that loop, I've got a nested if statement that says if the current car damage is greater than 0. So in this game, for what it's worth, we were tracking damage in terms of an integer. So if the current car damage is greater than 0, then set the caution flag to true. Okay, so it might be false for a while, it'd be false for a while, but at some point, if I see any damage at all, I set the caution flag to true. Now, after the loop, after the body of the loop, then I can have another if statement that checks whether the caution flag was ever thrown or not. So I'll have, after the loop, I'll have if the caution flag is true, then print out hazard on the track, or if I have an actual animated game, I'll actually trigger the flag waving animation at that point, is what we actually did. Okay, so a pretty good example of what we call a flag in programming, actually controlling a real flag in a video game, just like that. Now, let me just look at that last if statement there. So I've got if caution flag equals true. There's actually a shorter way of writing that. You could have written like this, right? You could just say if caution flag, then print out hazard on the track would do the exact same thing. Because of course, an if statement wants to see a Boolean in the parentheses, and caution flag actually is a Boolean, right? That's the whole point of what if wants to look at. So, whether caution flag is true or false will trigger whether the if happens or not perfectly fine. That's all the if needs. So saying if caution flag is equal to true is a little bit redundant, because it will be equal if caution flag is true, and it won't be equal if it's false, and that's all you really need. This kind of sticks in my mind because I think the first time I wrote a program in my college programming course, I wrote it long style, and the grader actually circled it in red and said, no, that's wrong. You can just write it like this. I think in my class, I probably wouldn't literally mark that as wrong, but I mean, it's not like they were incorrect about that. As programmers, we do like things to be shorter, so why waste writing the equals true? So they're right. I probably myself wouldn't take points off of that, but I do also prefer it the short way. Okay, so I think that's some pretty good information about the do-while loop. We commonly use that to repeat user-controlled loops, right? Take an action and then ask yes or no, do you want to do it again, is pretty common. And we also thought about the proper way, really, of doing input validation using a while loop, or you could use a do-while loop. Either's okay. And then we also looked in at the issue of using flags, which comes into play in this particular lab, actually, that I would do with my students the next time we're in person. So this is actually one of the longest labs we do in our first semester course, for what it's worth. This program, it has a menu for taking orders at a coffee shop, basically. So it's got a menu with a bunch of options for beverages, and then it asks, like, how many cups of this beverage do you want? And there's a switch statement to handle the different beverages and different prices. And then I think it's got input validation in there. It's wrapped in that, all that is nested in a do-while loop because it allows you to put in multiple orders at a time. And then we're also using a logical operator to handle uppercase or lowercase input. So quite a bunch of stuff that we've discussed in the last couple of weeks. Probably takes up about an hour in our lab, I'm guessing. But this is actually a very good lab. If you have access to this, give yourself a little time and see if you can complete that using the do-while loop, plus a switch, plus a logical operator, plus a bunch of other stuff. And I kind of like this lab quite a bit, actually. So when we come back in the next video, we're going to see the third of our 3 looping structures, which is the for loop, which is specialized specifically for the count-controlled situation, save some typing time. You see for loops a lot. Maybe that's the first thing we should have actually discussed, but in the book it comes as the third thing. So I'll see you then for loops.